Hey guys, and welcome back. Today we're going to talk about linear regression or scatter plots and just how to read them. Later on this week we'll look at predictions, and then next week some math, and that's it. So let's get right into it. So linear regression, we have some key terms. You need to write these down, and you also need to draw the graphs. So first thing we have is correlation. It is the spread of data. There are different types of directions. It is also the comparison of two variables. So bivariate data means two different variables that we're comparing. So if we were doing a survey and we surveyed two things, how do they relate? So we're typically staying in the first quadrant, but we'll use all four throughout the unit. So first type of data we have, go ahead and draw this down, make a little graph, and they don't have to be exact, but draw the dots in a negative manner. So negative decreasing left to right. So just like that. So go ahead, write that down, draw that, pause the video. Let's get rid of this. So next, we've got the opposite of negative, positive data. So this is increasing from left to right, okay? Go ahead, pause video, write this down, draw it out. So now we're gonna put some dots on this graph because we have different type of data. So if the dots are really close together, like closer to making a straight line, that would be strong data. If they're more spread out, then that would be weak data. So draw this graph out, label it strong data, and then pause the video and then come back. We're gonna spread these dots out. Okay, so the more spread out they are, the weaker the data is. So if it just looks like it's just not making sense because they're not close together, then it's weak data. It's kind of hard to read it, to read if it's negative or positive. So now let's go ahead and put some data on this graph again. So this type of data is just like super spread out. So this would actually be no correlation. There's no relationship between my X and Y. They just don't relate. So no correlation. Write that down, draw that out. And we are moving on. So let's look at our first type of data. If it makes a straight line, that would be a linear relationship. So that is anything that makes a straight line. Linear literally just means line. So straight line, okay? And this would be strong data because it's so close together. So what if we have something different? What if we have data that looks like this? So this would actually be non-linear. So a non-linear relationship does not make a straight line. So your 6 characteristics that you are using to describe lines are linear, non-linear, positive, negative, and strong and weak. So it can't be, a graph cannot be both linear and non-linear. It cannot be strong and weak, and it cannot be positive and negative. You have to determine what each graph is, okay? So let's go ahead and look at some data. So what if I'm given multiple graphs and I'm told, find the one that's linear? The first thing I'm gonna do is look at all my graphs and I'm gonna connect the dots. So we're playing connect the dots. So this first graph, I'm gonna connect these dots. Okay, so they're making kind of a line. It looks more like a curve though. The second one, they are making kind of a line. It's a little crooked, but it is more of a line than the first one. The second one is just, the third one is nowhere near. It's like a W, so that has nothing. And this last one is more like a smiley face. So we want to pick the closest one to a straight line. So I would definitely say B, that second graph, would be my linear relationship. So not the one with the curve, not the W, not the smiley face, the one that's like a kinky straight line. That would be my linear. Okay, so let's look at this data. What if we have this question? Which of the following points could be added to keep this data linear? So we want to know, if I add another coordinate point to this, how could I still make it a straight line or a linear relationship? So I have these 4 points. A is -2, 5, B is 3, 7, C is -11, -11, and D is 7, 1. So I'm always gonna take all 4 points and graph them. Something else you could do is draw a line through the middle of your data. This is called a line of best fit, which we'll talk more about on Thursday, but either way. So I'm going to put -2/5. I see that it's in the second quadrant, so it is nowhere near my data. Next one, 3, 7, again, first quadrant, nowhere near my data. Next, -11, -11 is right there close to my data. And 7, 1 is actually close to my data too. So we're trying to figure out which, between C and D, which one would make a linear. And it would actually be C. The reason why is because that is going to keep continuing linear and keep straight. 7, 1, if we really think about it, that 7, 1 is going to almost make a curve. And we don't want a curve, we want a straight line, okay? So it would be -11, -11. And that is it for today. Bye, guys.